Hi folks, and welcome to another episode of Open Analysis Live. So before we begin, just one follow-up on one of the comments that I saw. Someone asked us to introduce ourselves at the beginning of the videos. So my name's Sergey. I'm the shiny bald head and glasses, and Sean is the guy that has hair and a beard. So that's how you can kind of tell us apart. Both of us are the two halves of Open Analysis. One other comment or follow-up on the comments that I wanted to address is in a previous video, I mentioned that maybe we would put together a workshop dealing with API hooks and how to build like a sandbox with API hooks. So we are going to do that. It looks like there's enough of you wanted that. So look forward to that. It probably won't be soon, but I guess stay tuned if you're interested. So today we're going to talk about just quickly unpacking a sample. It's just going to be a quick unpacker tutorial. And what we're going to do is we're going to show you a quick little trick that you can use that might work and it might save you a lot of time. So basically, let's take a look at our sample first and then we'll talk about the trick. So right here we have a sample that I pulled off Malware Traffic Analysis. Awesome work from Brad. If you want samples to go in, practice your skills, I'll link his site in the description below. It's where I get a lot of samples and it's awesome work over there. So this sample is a kind of unknown crypto miner. Looking at the code after I unpacked it and took a look at it, it looks like a pretty straightforward script kiddie type thing, but it's an excellent example of this unpacking technique that I want to show you guys. So if we take a look at the process tree down here, we can see here's our original sample and then it runs a copy of itself. And generally when we see that, we think process injection, right? I covered this in another video, but anytime you see a process that starts a copy of itself, generally that means that they're going to try and inject code into the second process. But that's actually not the trick that I want to cover today. So it's even easier than trying to identify how the code is injected into the second process. You can actually circumvent that completely and dump the code earlier. And this happens if the packer is built using one of two Windows APIs. So if they use RtlDecompressBuffer or if they use CryptDecrypt. So these are decompression and compression, or encryption and decryption Windows APIs. So most of the time, packers will implement their own crypto algorithm or they'll use a third-party library for compression and encryption. Sometimes you'll get lucky though, and they'll use the Windows APIs for encryption and decompression and compression. So in this case, they're actually doing that. And so why don't we take a quick look at CryptDecrypt. So it's just a simple function where you pass in like the key and the buffer and the length of the buffer, and then they'll decrypt the buffer for you, and they return the decrypted information in the same buffer. So it's actually really easy to hook this and dump it out. So what we're going to do is we're going to run the sample in a debugger. We're going to set a hook on CryptDecrypt, and I'll show you what I mean. Now, one of the important things here is how did I know that they're using CryptDecrypt? Well, what I usually do is if I have to use a debugger to extract a sample, if I have to use a debugger to unpack a sample, I'll always hook CryptDecrypt and I'll always hook RtlDecompressBuffer because there's just a chance that maybe one of those will be hit before the other API calls that I have. So in this case, I'm not going to show you, I already did that. I'm not going to show you what I was doing originally, which was looking for process injection, but I just set these hooks, it's kind of second nature to me to set hooks on these two APIs just in case they're hit. And like I said, sometimes you get lucky and the packer will actually use one of these APIs. And if you do, it means you can pretty much stop unpacking. Basically, the reason why is because if they've encrypted the binary, so it's an encrypted blob inside their PE file, and they run CryptDecrypt on it, well, the buffer after CryptDecrypt is going to contain the decrypted binary, right? It's going to contain the decrypted payload. So you can just set a hook on it, check out the return buffer, and then you should have a PE file there. So so that's actually what I'm going to show you guys how to do here. So let's pop over to IDA. We have the binary loaded up already. I've called it coinminer.exe because I know it's a coin miner, but it originally had a different name. So here, if we want to just double check that this is packed, we can see first we look at our strings window here. We can see there are some strings, but not the ones that we would expect for a crypto miner. And then more telling than that is the fact that we only have a very small part of the binary that's been analyzed. So this blue means that it's actual code that IDA's analyzed, and all the rest of it is unknown data or unanalyzed data. So it's very rare to see a PE file that has only a tiny bit of code in it and a whole bunch of data unless it's a packed file. So anytime you see this like huge ratio of unknown or not code data to code data, it's almost certainly a packed file. So this is the standard trick that I usually use, where I'll set a breakpoint on the I'll set a breakpoint on start, and I'll use two VMs. So I have currently the VM with IDA in it, and then I have a second VM here I can show you in a second. So here's my second VM, which is just a Windows XP VM where I will start the IDA remote debugger. So here's the IP address that we're listening on. So if we go back to the IDA instance, we can set up a remote Windows debugger, and then we can set up under debugger, we can set up the IP address of the remote debugger under hostname. So it was 131. Okay, so you'll notice that I haven't set any hooks yet. I haven't set any breakpoints on any APIs. I've just set one breakpoint on start. And the reason for this is because I like to run until the start of the malware before I start setting breakpoints, because otherwise they're going to get hit, maybe during loading of other libraries and stuff like that. So let's run until we get to the start. I always like to view the advanced toolbar even when I'm debugging. So I turn that on and I want to see the full stack view. I don't really care too much about the output window. Just trying to make this look a little bit prettier so I can see what's going on here. And I want to see the modules. So we've stopped on the breakpoint here at the start of our malware. If we go back to CryptDecrypt here for a second and we find out what DLL is that contained in. So if we scroll down to the bottom of the documentation in MSDN, we should see here it's ADV API 32. So here's the DLL that it's contained in. So if we pop back over to IDA, we can look for ADV API 32. And then Control F, and we'll find CryptDecrypt. There we go, we pull it up, and then we can just set a breakpoint on the start here. Add a breakpoint, and then we'll run the binary until we get to that breakpoint. So it's doing its thing. Oh, and there we go. We've popped over and we've hit our breakpoint. So now it's kind of the interesting part here. So we need to go back to the definition of CryptDecrypt in MSDN, and we need to see what the arguments are that are passed to it. So let's scroll up here. So what we really care about is this data buffer and the length of the data. So these are, so this is on argument 1, 2, 3, 4, 5. Argument 5 is data and argument 6 is length. So let's go back to our IDA instance. Here is a view of our stack. So remember, the first thing pushed on the stack is the return address. So the arguments start one below it. So we have 1, 2, 3, 4, 5. So this must be the buffer that's being passed in. So let's copy that and we'll open a new window here and we'll jump to it using G, go to that address. So here's the buffer that's being passed into CryptDecrypt. And I like to save the length of the buffer as well, just so that if I have to dump the buffer out, I'll know the length of it. So the buffer was the next argument down on the stack here. So we can just copy this, and we can open another window here, go to that address, DDD. Okay, so it looks like that's the size, and we'll just save that for later. I'll just copy and paste that address over in here. And the buffer starts at 720000. And that's also in hex. Okay, so we'll pop back over to our IDA here. And what we can do now that we know where the buffer is and the size of it, we can actually just use the run until return, so that we return, basically we run until we return from CryptDecrypt, and then we can take a look at the buffer. So there we go, we returned from it. So let's take a look at our buffer here. Hey, look at that, we have the nice MZ header. So that's how fast it is. Literally, it was like, less than a minute to unpack this. And now all we have to do is dump out that buffer. So here's a kind of interesting trick that I like to use. I have a very small, very short IDA script that I use just to dump out buffers, and I'll also link that. I'll link the gist below in the description. So I'm just going to load that script up here, script file, and memdump.py. So now that our script is loaded, we can just use the help function here in the console. So help for memdump, and we can see what the arguments are. So the first thing that we need is we need the address of the buffer, then we need the size of the buffer, and then we need the file that we're going to write the dump out to. So luckily we already copied those and we store them in Sublime here. So all we have to do is we just have to copy the size and the buffer over and call memdump, and send it out to a file. So pretty straightforward. Memdump, and then the buffer is here, and the size is here. And then we have the file. So on my VM, I've mapped the temp drive of my host to the Z drive on the VM, and I have a folder called work. So I'm going to store stuff there. So I'm going to do Z temp work, and let's call it dump.bin. There we go, memdump success. So now that we've dumped it out, let's open it up in IDA and see what we've got. Okay, so we've opened up dump.bin in IDA, and the first thing I want to do is just check the strings here and see what we've got. Yeah, and so here we go. We can see the strings that were passed to one of the binaries that we saw in hybrid analysis, so we know that we've actually unpacked the sample. So there we go. Super quick trick if you're trying to unpack stuff. Always hook CryptDecrypt and RtlDecompressBuffer. It's always worthwhile just in case you hit one of those while you're doing your debugging, because then you can check the output from them and see if maybe you got a PE file. And it's just a quick way to circumvent the entire packer, basically. So hopefully you enjoyed that. Nice short unpacker. Keep on leaving us comments below. Let us know what you'd like to see next. We're definitely taking in the ideas. It's way more helpful to have stuff on YouTube now that you guys can comment directly and let us know what you want to see. And as always, keep exposing the mechanics behind the malware and stay curious.